You will visualize a demonstration of IMPEx capabilities through an example of the interoperability between data time series visualization on AMDA, the simulation database, LatHyS, and its data products, as well as the VO tool Topcat. We will focus on the possibility to make comparison between Mars Express observations and simulations of the Martian-induced magnetosphere. In situ observations are very helpful for improving our knowledge of the solar system objects and their environments. However, observation missions are limited in time and space. In the case of missions with a unique spacecraft, like Mars Express mission dedicated to Mars, it is impossible to dissociate spatial and temporal variations in the measurements acquired. Simulations performed using numerical models of Mars' interaction with the plasma ejected by the Sun, the solar wind, allow avoiding these constraints by reproducing the Martian environment as faithfully as possible. They are complementary to in situ observations of the plasma environment of Mars. First of all, we will use AMDA, the Automated Multi-Dataset Analysis Service developed by the Plasma Physics Data Center, CDPP. AMDA is helpful to make simple representations of time series of in situ observations in the domain of space plasma physics, and it is an excellent tool to browse the data and look for events. With AMDA, we will visualize protons' characteristics measured by Mars Express Ion Mass Analyzer, IMA, namely the velocity, the density, and the temperature. We will also display the ephemerides in cylindrical coordinates. Data are available on CDPP database and can be plotted simply by dragging the parameters of interest to the plotting window, meanwhile indicating the time interval of interest to us, namely the 12/7/2007 between 0 and 12. Then we click on Plot. Mars Express trajectory in a cylindrical coordinate system is presented in the top panel. We can see on the plots that the spacecraft is firstly in the solar wind and then it crosses the magnetosheath region. Finally, it travels into the induced magnetosphere, where we can note that the density and the velocity are very variable. Now, we intend to compare the velocity along Mars Express trajectory during this time interval with simulation results. The VO application Topcat will help us. Thanks to the interoperability capabilities between AMDA and Topcat, it is possible to automatically transfer the data that we have selected and plotted into Topcat. We start Topcat and we activate SAMP, the Simple Access Messaging Protocol. In AMDA's plot window, we click on Get Data. The Download Data window shows up. In this window, we can choose downloading options and load data in Topcat using SAMP. Once the loading is completed, we see the table corresponding to the selected data in the Table List section of Topcat. By clicking on this icon, we can see the table columns. All parameters plotted in AMDA appear here. Let us now select and load the simulation data. We will use simulation results from a 3D multi-species parallel hybrid code developed at LatHyS, which describes the interaction between Mars and the solar wind. On LatHyS Hybrid Simulation LatHyS website, we can choose data of interest, which are, for the present study, 2D cuts of the characteristics of thermal plasma from Mars_13_02_13 simulation namely the electron density, the plasma bulk velocity, and temperature. Basic parameters for which the run has been performed are indicated in the right side of the web page. We register to SAMP Hub in the bottom of the page, and after selecting the data product we want to transfer to Topcat, we click on Send. The new table loaded in Topcat appears in the table list, and we see corresponding parameters in the table columns window. We will display on the same figure in the XZ plane the x component of the proton's velocity measured along Mars' expressed trajectory during the selected time interval, and the x component of the proton's velocity in Mars' vicinity resulting from hybrid simulations. The x-axis corresponds to the direction of the solar wind bulk velocity. The z-axis corresponds to the south-north direction. We begin by plotting the simulation results. Then, in the plot window, we add a new dataset to overplot Mars Express observations. There is a good accordance between observations and simulation results. Finally, we see that it is possible to identify interesting events and confront in situ observations with simulation data products. This was performed a simple way thanks to interactive framework facilities developed by IMPEx team. Thank you for your attention.